In this video, we're going to talk about powers of whole numbers. Well, you know what? Let's change that to integers. Powers of integers. Now, recall if you had 2 plus 2 plus 2 plus 2 plus 2, we would simplify that by writing 2 times 6. And if you had 8 plus 8 plus 8, 4, 5, 6, 7 times, this would be 8 times, simplified as 8 times 7. And if you had to write 13 plus 13 100 times, which I'm not going to do, this would be simply written as 13 times 100. So repeated addition has a much simpler way of writing it using multiplication. Okay, I wrote a lot here. I mean, a lot's relative. I wrote a lot here, and I wrote a lot less here. I wrote a lot here, but much less here. I wrote a lot here, and here I wrote less. Nice notation. Well, let's up the level a little bit. Here we have repeated addition. What if we had repeated multiplication? What if we had 3 times 3 times 3 times 3 times 3 times 3? Be nice if we had a simpler way of writing that. And we do, fortunately. Basically, since we just repeatedly multiplying 3, we write 3, and up here we write how many times we're multiplying 3 together. 1, 2, 3, 4, 5, 6. That is why we have our 6 up here. If you had 2 times 2 times 2, etc. for 7 times, the numbers that is repeatedly multiplied goes where I put the 2, and 3, 6, 7 times. The number of times we're multiplying it goes up there. So if somebody asks you what 2 to the 5th is, you should think this. For example, that's 4 times another 4. 4 times 4, don't forget that 2. 4 times 4 is 16, and if we multiply that by 2, we get 32. So 2 to the 5th, by definition, is 32. Now, let's talk about how you read this. 5 to the 4th is read as 5, the base, 5 raised to the 4th power. 4th power. If you have 11 to the 7, this is read as 11 raised to the number of times we are multiplying 11. And it's 7 times. So it's raised to the 7th power. Now, 3 squared is, 3, this symbol is read as, I guess I realize I have been reading it, is read as 3 raised to the 2nd power. Now, when the power is 2, there's a special name, or it's read as 3 squared. If the power is 2, you read it as the 3 squared. If it was 13, you would read it as 13 squared. So for example, 7, that symbol is read as 7 raised to the second power, or as 7 squared. We have a similar alternative way of writing things when it's cubed, when it's raised to the third power. 13 to the third power, it is read as 13 raised to the third power, or 13 cubed. When the power is 3, we can say cubed. So this is read as, not 13, excuse me, is read as 7 cubed. Now, some people, including myself, we don't say the word raised. Okay, let's go to the higher ones, the ones up here. You can read this as 5 to the 4th power. This can be read as 11 to the 7th power. It's up to you whether or not you say the word raised. It wouldn't be right, or it wouldn't be wrong if you didn't say raised. It wouldn't be wrong if you did say raised. It's up to you. You can read this as 7 to the 2nd power. But since it's one of the 2 special powers, it's also 7 squared. Okay, you can read this here as 11 to the 7th power. It's read as 11 to the 7th power. It's up to you whether or not you want to say the word raised. You can say it, you cannot say it, it's up to you. Now, let's talk a little bit about notation. When you have 12 to the 6th, that number is called the base, the number that's being repeatedly multiplied. And the number of times this is being multiplied is called the exponent or the power. So, whenever you have a to the b, where a and b are numbers, the a is called the base, and that's the exponent or power. So if I asked you in this expression to denote the exponent and power, you can say that the exponent is 3. Identify the base or the exponent. And the base is 8. That's the base. That's the exponent. Now, let's look at what happens when you divide such things. What if you had 2 to the 7th divided by 2 to the 5th? Well, if you just do things by definition, things would work out nicely. Before you divide, know what you're dividing by. You cannot say that, oh, this is simple. 2 over 2 is 1, so I don't know, the answer is that. No. You can't divide the 2's. Why? Because this is not 2, and that's not 2. 2 to the 5th is 32, and 2 to the 7th is 128. So let's see how you can do this. Well, by definition, 2 to the 7s means that. And 2 to the 5th means this. And I know one thing. 2 over 2 is 1. 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 And when you multiply all those 1s by this, you're just going to get 2 times 2, which happens to be 4. But why were there 2 2's left over? And the answer, I hope, is obvious, because that power is 2 more than that power. It's 2 to the 7 minus 5, which is 2 squared, which equals 2 times 2, or 4. You can just subtract the powers. If you had 4 to the 6 divided by 4 to the 4. Well, by definition, the top is 4 times 4, 6 times. And the bottom is 4 times 4, 4 times. Oh, 4 over 4 is 1, 4 over 4 is 1, 4 over 4 is 1, 4 over 4 is 1. So the final answer will be these numbers times those numbers. But these numbers just multiply out to 1. And 1 times 4 is just 4 times 4, which happens to be 16. Now, why were there 2 4's left over? Oh, that number 6 is 2 more than 4. An easier way of doing this, rather than doing all this, is you can say, well, let me write it. 4 to the 6 over 4 to the 4 is 4 to the 6 minus 4, which is 4 squared, which is 4 times 4. If you want to write that, write it. If you want to do it in your head, you don't need to write this. But 16 is the answer. Now, let's look at something over here. If you have 3 to the 5th over 3 to the 5th. Now, 3 to the 5th is some number. If you multiply these 3's by itself 5 times, you'll get some number. So the top is going to be some number, and the bottom is going to be the same number. You divide the same numbers, you get 1. On the other hand, using the rule, it's going to be 3 to the 5 minus 5, which is 3 to the 0. Interesting. 3 to the 0 is 1. Now, even if I had 13 to the 5th, you divide 13 to the 5th by 13 to the 5th, you're going to get 1. But it's also 13 to the 0. So 13 to the 0 is 1. Now, what if you had 13 to the 51 divided by 13 to the 51? You're still going to get 1. And when you do 51 minus 51, you're still going to get 0. This is telling us that x to the 0 is 1. Now, there's only one time when you divide the same numbers and you don't get 1. 7 over 7 is 1. 9 over 9 is 1. Negative 3 over negative 3 is 1. 0.24 divided by 2.24 is 1. You divide the same numbers, 7.31 divided by 7.31, you get 1. But you know what? 0 divided by 0 is not 1. Now, let's just look at something. Is 7.31 over 7.31, does it equal 1? Well, 7.31 times 1 any number times 1 is going to equal that number. 7.31 times 1 does equal 7.31. That's correct. Just like 10 over 2 equals 5, 2 times 5 is 10. But you know what? 0 times 1, it does equal 1. But you know what? 0 times 11 is equal to 1. 0 times 114 equals 1. This tells us that this is indeterminate. We can't figure out what it is. It can be any number. Can 0 over 0 equal 0? Sure. Why? Because 0 times 0 equals 0. Can it equal 10? You better believe it. Because 0 times 10 equals 0. Can it equal 104? Absolutely. 0 over 0 equals 104. Because 0 times 104 equals 0. But now, here's the problem. Is 0 over 0 can equal any number? Now, we know that 7 is equal to 7 times 1. But 0 over 0 being any number, it equals 1. So yes, this equal sign is right. 7 times 1 is equal to 7 times 1. But you know what? It also equals to 7 times 100. Because 7 is 7, times is times, and you know what? 0 over 0 is also 100. 700. So if I owe you $700, if I owe you $7, you can say, hey, you have to pay me back 700. Why? Because 0 over 0 can equal 1, and it can equal 100, which is nonsense. We can't let 0 over 0 equal any number we want. We cannot let 0 over 0 equal any number that we want. That is why we call it indeterminate. We don't know what it is. Now, x to the 0 is equal to 1 if x is not 0. For example, 7 to the 5 over 7 to the 5, it's 1, but it's also 7 to the 0. You divide the same two numbers that aren't 0, you're going to get 1. But now, if you have 0 to the 5th, which is 0, divided by 0 to the 5th, which is 0. 0 times 0, 5 times is 0. This is not 1. Because 0 over 0 doesn't equal 1. It's indeterminate. But this does equal to 0 to the 5 minus 5, which is 0 to 0. This is also indeterminate. I don't know what this is. Why? Because it came from the top number, 0 to the 5 is 0. The bottom number, 0 to the 5 is 0. 0 to the 0, 0 over 0 is what gave us 0 to the 0. After all, this is 0 over 0, and it's also 0 to 5 minus 5, which is 0 to the 0. It's indeterminate. Okay? X to the 0 is equal to 1 as long as the base is not 0. Okay, so very, very simple problems. 2 plus 3, which is not 0, it's 5, to the 0 power is 1. 7 minus 2, which is not 0, to the 0 power is 1. 7 to the 0 is 1. Negative 7, this is to the 0 is 1. That number is not 0. I don't care what it is. It's not 0. So when I raise it to the 0 power, I get 1. 7 over 2, that is not 0. When I raise it to the 0 power, I get 1. Now, 17 minus 17, that's 0. And when I raise it to the 0 power, I get indeterminate. But if I had 17 minus 2, which is not 0, it's 15 to the 0 power, I get 1. Now, since I talked about 0 over 0 is indeterminate, that is 0 over 0 can be any number. What about if the numerator is not 0 and I divide by 0? What can I put here? Now, whatever I put here, 0 times that number is supposed to be 7. Whatever correct number I put there, 0 times that number should be 7. But you know what? No matter what I put here, no matter what I put there, 0 times that number is going to be 0. And 0 never equals 7. It certainly isn't 8, because 0 times 8 is 0. It's not 7. Well, some students will say, oh, it's negative 7. Nonsense. 0 times negative 7 is 0, which is not 7. So, oh, it's 0. Well, 0 times 0 is 0. It's not 7. No matter what number you put in here, I couldn't care what number you put in there. 0 times that number, which I can't even read, is 0. It's not 7. This tells me that 7 over 0 is undefined. And if I had 17, it'll still be undefined, because 0 times no number will ever give me back 17. And if I had 174, it is undefined. If the top is not 0, let that symbol mean not 0. You have a non-zero number and you divide it by 0, it is going to be undefined. Why? Because 0 times no number is going to give you back a number that isn't 0, like 7 or 2.4 or negative 9. This is undefined. So if the top is 0 and the bottom or the top is not 0, you still can't divide by 0. You cannot divide by 0. If the top is 0, we call the division indeterminate. If the top is not 0, we call the answer undefined. In the end, you can divide by 0. So that is why x over x is not 1. I don't care what your teachers tell you, they're mistaken. X over x is not 1. X over x is equal to 1 if x is not 0. You can't compute 0 over 0. At some point, you'll learn about piecewise functions. It equals x over x equals 1 if x is not 0, and it equals to indeterminate if x is 0. X over x is indeterminate if x is 0. It's not always 1. This completes the section on powers of integers. I just want to make one quick comment. Initially, I was about to write powers of whole numbers, and the reason that I didn't write powers of whole numbers and I changed it to integers is because of this one problem here. That number is not an integer, and I'm raising it to a power. Okay, this is, sorry. This is not a whole number. This is not a whole number, but I'm raising it to a power. So to make this part of this section, I changed that the base can be an integer. -7 is an integer. Okay, that is why I put integers here. I have an integer raised to a power. This will be -7 times -7. Multiply the base by itself 2 times. That gives us 49. Because I guess you don't know it yet, but a negative times a negative is a positive number. This completes this section.